Hi everyone. So today we're going to be talking about analyzing the factor form of a polynomial, meaning like we're going to look at the zeros and remind ourselves how we find zeros first, and then look at them and say, what do they tell us about the shape of the graph at that point, or what's happening with the polynomial at this point. So we're really trying to get into describing the graph. And then we're going to talk about relative mins and relative max, which is related to turning points. So the first thing we're going to talk about is finding zeros and multiplicity. Okay, so what we mean by multiplicity is how many times is that zero a root? Shall we say, is the zero a solution? Let's use the word occur. Let's rephrase that. How many times does the zero occur? Okay, so for example, if x minus 2 is a factor twice squared, that means we have two x minus 2's, correct? Which means x equals 2 occurs twice as a solution. So it occurs twice. That's what we mean by multiplicity. If the root / 0 occurs more than once, okay, that's what we mean by multiplicity. So remember, to find zeros, we're going to use our zero product property. So we're going to factor first. So we're going to factor first. And remember, that includes GCF and our factoring techniques. Okay, well, that includes box, split distribute, FOIL. Okay, so I'm just going to put factoring there. And then we're going to use our zero product property. Okay, remembering that means setting your factors equal to 0 and solving. All right, so here is our theorem, shall we say, or our statement about multiplicity. So if A is a zero, a multiplicity n in the polynomial function y equals p of x, then the behavior of the graph at the x-intercept A will be close to linear as n is equal to 1, close to quadratic when n is 2, cubic for n is 3. What was I typing when I did this? And so on. So basically what this means is that if it occurs once, it's a line. Twice is a quadratic or U-shaped. 3 times it's cubic. And we even talked about cubic before, but it kind of like an S or a weird N shape. Okay, and so on. 4 would be quartic, 5th would be quintic. Okay, and so we're describing the graph. So here's our example, x squared times x plus 1 times x minus 6. So we're going to let each of our factors equal to 0. Okay, so x squared, that means there's 2 x's. So 0 occurs twice, so that has a multiplicity of 2. So this would be x equals -1, x equals 6. Now we don't usually write multiplicity of 1 or multiplicity of 6 because they occur once. So -1 and 6, okay, those are going to be where it crosses the x-axis at that point. These are going to be line-like. Now I'm going to graph it and I'm going to show you what I mean by line-like. And because 0 occurs twice, it's going to be quadratic-like. Okay, so what do I mean? So I'm going to put this in my calculator. All right, so I got x squared times x plus 1 times x minus 6. Okay, we're going to graph that. Let's put it back in Zoom Standard. All right, so at 6, do we see how it goes straight through the x-axis? It's almost like a line. At -1, we can see, zoom in a little bit. Okay, we can see it goes through the x-axis. But at 0, see the U? U-shaped. That's quadratic-like. So that tells us what the graph, what's going on there at that point. Where here at 1, it goes through. It goes right through. Straight, not straight, but pretty line-like. All right, at the graph. And that's what we mean by that. All right. Okay, let's try this one. Okay, it says x plus 3 quantity cubed. That means that x plus 3 occurs 3 times. I'm only going to write it once. X is equal to -3. So -3 has a multiplicity of 3. Which means that it's cubic-like. Okay, so what do we mean by cubic-like? Well, let's put it in our graph and see what it does. Okay, so I'm going to press Zoom Standard. Always press Zoom Standard, put it back to where the standard form. Okay, so you see, it's kind of goes up, has a little dent, and comes like keeps going up. You can think of it as a sideways S. I'm not really sure how to describe that shape, but that's where it goes through. It goes through at 3, so it's kind of like an S or a slight curve to it. That's cubic. All right, so that's what we mean by cubic-like. All right, let's try this one. Okay, so I'm going to take out a GCF of x. So 2x squared plus x minus 1. We're going to need to factor that, so pick your method, box, split, distribute. Okay, I use guess and check because that's how I was taught, back in the Stone Age. Then I'm going to set each of these equal to 0. So that means 0 and 1/2 and -1 are solutions. They all occur once, so I'm not going to write multiplicity of 1, but they all have line-like at that point. So again, if I put in my calculator, okay, 2x cubed, 2x cubed plus x squared minus x, and again, press Zoom Standard. Always put it back to where it belongs. Okay, and if I graph it, I know it seems like it's kind of curvy, but at -1, it goes through like a line. At 0, it goes through like a line. At 1/2, it goes through the x-axis. At the x-axis, so we're talking about what's happening at the x-axis. So they are all line-like. Okay, so try 3 and 4. Use your calculator if you need help. Okay. All right, so I'm going to put that back over there. All right, so 1 occurs 3 times and 0 occurs once. So at 0, it's going to be line-like. At 3, it's going to be cubic-like. Okay, and number 4, okay, we're factored, and actually 0, 1, and -1 are all multiplicity of 1, so they're all line-like at that point. Okay, so notice we're describing a graph. We talked about end behavior. We've talked about number of turning points. We talked about what the graph looks like at the x-axis, at the solutions, which is x-intercepts. Okay, so now we're going to talk more about that turning points. So relative min and relative max as related to the number of turning points. Okay, so we're actually going to find where those turning points occur. So remember from the other day, we said the number of turning points is the degree minus 1. And then we're going to do that answer minus 2. Okay, for compensating for our imaginary friends. So this is going to be kind of like, where are those turning points and what do they look like? Okay. All right, so we have two different types. They're called relative min and relative max. We're never going to say just the max or just the min because remember we talked about in behavior going toward infinity, toward all the way up or all the way down. Okay, so that's where our maximum will recur. Relative means within a certain interval. Between what two x values is this going to occur? So relative max is the value of the function at an up to down turning point. Here's our turning points. Relative min is the down to up turning point. So relative min goes from down to up, and max goes from up to down. Okay. Not every graph has both. You can have more than one. You can have two mins and one max, and two maxes and one min. You can just have a min. Okay, so depending on the graph, okay, is going to determine what kind you have. So we're going to find the relative min and relative max of x cubed plus 3x squared minus 24. Okay, so the way we're going to do this is we're going to graph the function in our calculator. All right, that's going to be the easiest way. There is an algebraic way. We're not going there. That is way beyond what we need to do. So we're going to take our function. I'm going to write it over here because I'm not going to remember it to put it in our calculator correctly. Okay, so go to y equals, press clear. Now, when we put this in, we're going to look for where is our highest and lowest points, if they exist. Oops, forgot something. Sorry, there we go. Press graph. Again, zoom standard. Everything put back to where it begins. All right, so I definitely can't see it. Oh, there we go. Now it comes into shape. See it? Okay, now the beauty of our calculator, and I love this about it, is that you just tap it, and it gives you a cursor that you're going to move. And look at that. It tells you it says max. Okay, it tells you that it's the max. So our relative max and up at the top, you're going to see the equation and you're going to see the ordered pair. X is -4, y is 80. There you go. Okay, then you're just going to move your cursor. It also tells you where it crosses the x-axis, so you could check your answers. And it tells you your min. It says min to -28. That's all we're doing. Okay. All right, let's try the next one. Okay, so we have, I got to put it over here because I can't read it with my calculator overlaps it. There we go. 3x cubed plus x squared minus 5x graph. so again, I press zoom standard, it takes you back to where it belongs. All right, so again, we can see, and again, you're going to move it until it highlights max. Negative point, let's make it 2 decimal places, comma, 3.13. Notice this is not, they're not going to be nice numbers. Okay, there's a lot that are going to be decimals and fraction decimals and non-terminating, non-repeating decimals, things like that. Okay, relative min. Okay, so 0.64, and I'm going to say that's -2. And there we go. Okay, relative min, relative max. All right, let's try one more. Again, let me write it over here. Should have given us the next to the 4th one. Zoom standard. There we go. We can see them a little bit better. Okay, so we got relative max. Now, all the problems we did were x cubed, so I should have given us more variety. We'll do some more in our warm-up. Okay. Press our button. Look at that. Okay. 0.57, comma 17. Let's make that 17. Remove that. Look at that. That's a 0. That's one of the answers, like if you factored it. There we go. Here's our relative min. .09. Oh, let's make it 4.1, comma -5.5. All right. So we're going to be using that calculator to help us out with our solutions and stuff. So please make sure you have that and you can access it. All right, so hopefully we met our goals today, which is looking at analyzing the factored form, discussing what is happening at those solutions. Remember, that's where the graph crosses the x-axis. Those are solutions to the polynomials. What is happening to the graph at that point? Is it line-like, quadratic-like, cubic-like? And relative min and relative max, basically highest and lowest points on the graph. All right, guys, let me know if you have any questions. Please stay safe out there.